Hi guys, it's Dr. Muhammad Usman, and today I will be talking about data visualization toolbox. It is part of our data visualization training series, and I will start directly by talking about data visualization toolbox and an overview. So we will be talking about two main items in this one. One will be the perceptual coding and second one is the interaction. Other than that, we will be talking about the information density, and we will be applying the actual principle which we have read before in our visualizations, like in Burton 1, maximizing the data ink ratio, maximizing the data density and minimizing the life factor. So we will be checking about different visualizations which are already built up according to this all set of coding, and this toolbox will be helping us to identify different visualization and what they actually mean to us in the data integrity or the visualization integrity matter. So first of all, as we have seen that if we have raw data, then we do its selection and coding, and then we present it, and the viewer is able to view that data. But when I talk about the design interaction and about the data visualization toolbox, I will be adding some more things. If you can view over here, I will be adding interaction, and interaction is basically the data visualization toolbox. We'll be using some model parameter like in the data visualization toolbox, and we will monitor the performance before it is converting into the raw data, and we will be knowing what parameters are required according to the data visualization toolbox for building up a proper visualization which has all these things important embedded in it. So basically the data visualization toolbox will be providing you an interaction tool, and it will increase your interactivity in your visualizations. So I have some examples over here which I will start. So the first example over here I am having is the film finder and the Starfield display. Basically these all examples will be of different softwares and applications which are already built up to give you an overview that what kind of toolbox is applied to different visualization and interactive visualization. So basically we have this one which is about working on the dynamic queries and making them show in a tight coupling environment over the interface components. It will also help you to analyze the immediate feedbacks, and it will also, and this one further help you for the details on the demand one. So let's look about the data visualization toolbox, like how it is applied on this visualization. So first of all, the star fields look like this one. We have a window in which we are having different small items like stars scattered in the sky, and we apply the perceptual coding over here. Then we have the overall data over here. Like if you see that the position is the very first variable, we are checking that either position is available or not. So if we can view it in form of the visualization, we can see that. So if we just talk about the very first perceptual coding variable, it is the position one. If you can see, it is written as yes. So why it is yes, I just tell you that if we see the position of these variables, so these variables have a certain distinct position in this diagram. And if we look out for the other variable, then if we zoom in to them, we can also view the other positions of this variable. But when we talk about the size, then it is no, because the size of these all variables are the same. If the size is differentiating among different variables, then we can say that size is different. Similarly, like there is no orientation or texture over here, it is just different colors, and color is already yes. And if you see that motion of these variables, so actually when we go into the Starfield animation, we can see the animation of these all the particles in our software. Then we see about the talk about the proximity and similarity. Yes, these are all similar to each other and they are proximate to each other, their size is equal to them. This was just the perceptual coding part. And if you talk about the interaction one, we can just go on the direct manipulation, because we can just click on different variable and just interact with that. Immediate feedback is accurate, because when we click one variable, it will tell us what is the value. There are link displays, because we can just move the display over this slide or in our software, and we can further monitor that which variable is moving from which year to and what is the value of that one. We also have the dynamic slide, like I am talking, we can move from one window to another window by sliding it. So we have the dynamic slider. Semantic zoom is that I can zoom into this one. So I have a zoom over here which is given in this one. I can just click and zoom into my software, and I can see the other variables in a greater form. Then there is details on demand and output to input. So details on demand is that if I click and get to details of each of these elements, then I can get it. So basically details on demand will be applicable when we need to get details, and when we can zoom in, when we can apply different functions on it. And last one is the output is to input. Output is to input is clear, because when we click up any variable in this one or any size of the star field or any element in this one, we will be able to match up it according to input our data table or our data variable. So basically this is journal overview of different star field activities and its perceptual coding and interaction. Similarly, like I will talk about more one, there is perspective wall, which is basically a fisheye distortion to increase the information density, and it is used to show greater information in just one window, and we can just move over to different columns to view the different information. And when we talk about its perceptual coding, it is just position one we have having yes, because we can go over the different position of the variable. Size is also yes, because we just click on the size of different elements, and when we can look into the second window or right side of the window, you can see different variables have different sizes. So size is changing in this one. We don't have any orientation because these labels are not tilting over here or any there. And there is color, yes, there is color in this one. We have shape, yes, there is a shape of boxes one over here, and the shape is proper of this whole image also. When we are talking about the shape, we will conclude both things. One will the shape of the actual element and shape of the whole diagram. Where we have a surface, yes, we have a surface down over below, which is a kind of texture. We can motion over it, and we have a proximity and similarity, because some boxes are similar or some boxes are proximate on each other. We have a containment. Containment is basically when most of the elements are contained in just one container. So in this one, we will be having different elements contained in just one container. So it is this one applied on this one. So talking about the interaction, yes, we have the direct manipulation, we have the immediate feedback, we have the logarithmic shift of the focus. So I will tell you when we have the log shift of the focus, basically it is when we can shift from front side to right side. So when we are moving in this one perspective wall, we can see different perspectives or the focus of different walls. So when we have the shift of the visualization, then we call it logarithmic shift. Similarly, like we will have the dynamic sliders, and focus plus context will be there when we have focus on each element and we can see the context. So this was just the overview of the perspective wall, and why there is detail not in demands, because there are no further details given on this variable. When you will click any label, you will not see the actual variable behind this one. You will just see the label, and you cannot track back it to its input. So basically it is just no for the output to input. So further moving with the hierarchical information and other trees which we have read already, and we will read in our next visualization. We will be having different node trees which are 2D, 3D, cone tree. We will also work on sunburst or hyperbolic tree, and there can be 3D trees also. So I will also give you some information and perspective coding of the trees and tree maps. So first of all we will be studying the tree maps perceptual coding. It is very easy because tree maps are used to fill the space. They have a structure like if you have studied the trees, they have some leaves, and each leaf is considered as a node, and we can transfer from the height to lower and from breadth to depth. So basically we will be having both of them. So when we talk about the tree maps, they look like this one. We will be also using the table view software, and we talk about the tree map perceptual coding. So position is yes, and we can see that different elements have different size. So size is also yes. We have a texture because different elements will have a different texture. So it is also yes. Color is also yes. We don't have a shape because according to the data, the shape will be changed. So shape is not fixed. Motion is yes. Then we're talking about the proximity. So different variables of each size will have a proximate value, and we talk about the containment. Then yes, there is a containment. Similarly, like when we talk about the interaction, so you will be getting to know why there is no logarithmic shift of focus, because we cannot shift it to different windows or different perspectives. So we don't have any focus windows. And similarly, like you cannot track back it to the actual value, because our whole box will be telling you just the space or the availability of the variables or the number of variables in just space. So that is why the output cannot be tracked back to the input. Similarly, like when we talk about the tree maps, we have slides and dice one, which are just clear to each other, and which are of different shapes like rectangular, squares, and it is just according to the different spaces. So and the tree maps differ according to this one. When we talk about the scary feed, this is basically that these all boxes will be scared whether of any size. So slice and dice will be according to the space, and scare feed will be according to the just one shape, which will be scare. So basically if I talk about the triangle feed or rectangle feed, so it will be just all shapes will be of rectangle. So basically this one was of the tree map, and when we further go into the hierarchical contribution of the tree map, then there is radial spacing, and radial spacing is also used for contribution of the hierarchical data. And the most important one over here which we comes is the sunburst, and sunburst is according to this one is a similar kind of radial tree and hierarchical data, which is just used for space filling, and it also display you different amount of data, and you can also generate the perceptual coding of it easily. The last one over here we will be studying with the hyperbolic tree. Basically hyperbolic tree is a tree which gives you many different nodes, like 100 to 1000 nodes, and they can also tell you about the focus plus context techniques, and also the logarithmic shift of focus. So basically when we talk about the hyperbolic trees, we can just apply this one perceptual coding. We talk about the position, this is yes. We talk about the size, yes, we have a definite size, and size is changing over here. We have shape, yes, we have a shape, there is a hyperbolic space, that is the shape. Then we have a color, yes, over here this is black and white, no other one. That we have a motion, yes. When we click on the hyperbolic tree, actually when you will click on it in your presentation, or when you are reviewing in the classroom, I will just show you it is moving in a circular motion. So basically it has a different function. When we go on the PPT, we have the connectedness, yes, these all are connected to each other. So you have got that what elements will be connected, basically which have different nodes. Interaction is yes, and we go on the image feedback, yes, it is over there. Shift of focus is there. We don't have dynamic slider because we have a limited space where we can have a semantic zoom, and we can see the different nodes. There is detail on demands, and also over here we cannot track back to the actual value of the node, so there is no output to input. So basically these all things are related to the interaction, and interaction has many different benefits, like I have over given here direct manipulation. It has a reduced short-term memory load, immediate feedback, just permit easy reversal of the action. Link display will be providing you the increase info density, animated shift of focus is similar. So I have different parameters over there, and these are all used for benefit of your visualization. So this lecture was up to here, and if you like this video, do visit my YouTube channel and like or subscribe to it. And as I told you, if you are taking this session from my YouTube channel, you can earn the certificate, and electronic certificates are free. The total process for the hard copy certificates are given over here, and you will be getting an authentic certificate according to your knowledge and according to your certification level. And if you are taking a classroom session with me, then you can apply for the data visualization certification, and I will be telling you in my first lecture, and I must have told you about the certification level, that how you can use it and get the certification. So what you are waiting for, go today and get your certification or training certificate. Thank you.